Awesome. Welcome everyone to the kickoff for TCL 17. Hooray. So excited. I'm so excited about this group. So the agenda for today, so we'll do a quick round of introductions. We've already really gotten to know one another a little bit already, so that's fantastic. But we'll do brief intros where we'll do name and pronouns, remind us again where you're from, and then why don't we say something that we're excited about for this upcoming TCL 17. So after intros, then we'll segue to Chris, who's going to do a really great presentation on Git basics for us. This is a new presentation for TCL, so I'm super excited. Then we will go to Mike, who's going to walk through this week's issues with everyone. And then we'll spend the last part of our weekly sync setting up branches for the week coming up. Super exciting, hooray. Okay, so I'll start with me and then I will pick someone, and then after you've done your introduction, then pick the next person, please. So again, my name is Lauren Beatty. I am from Minnesota, where it was like above freezing today, so that was exciting. Let's see, what else can I tell you? What are my things? Oh, she, her, hers are my pronouns. And I always love the beginning of the cohort because I just really enjoy getting to know new people, and like I'm a super introvert, which is ironic, but I love just getting to know a new group and to discover like how the group is going to work together, my mentors and participants included. I'm super excited about our mentor group. So and also I think this is the first time that the participants have arranged ahead of time to meet, like before the cohort started. So I'm pretty excited about that. That's really awesome. Yay. So I will pass it off to Rachel. Why don't you go next?
Thanks, Lauren. So Rachel, pronouns are she, her, hers. I'm from Seattle, Washington. And I think I'm most excited or most looking forward to the remote collaboration with like more of the team feel. I did the boot camp and we had it because we transitioned to remote with the pandemic, but I think that this is like super focused on it. I'm just really looking forward to seeing how that shapes my skills. And I will pass it over to Brittany.
Hello, I'm Brittany, and pronouns are she, her, hers. I'm in Portland, Oregon, so I feel bad about complaining about being cold now, hearing Lauren's story. And I'm really excited. When I was first learning React, I just felt really overwhelmed, and I feel like I didn't really process a lot, so I've been studying it super hard, and so I'm really excited to work on this project now with some of that new knowledge and to learn from everyone else here and get to share that. So yeah, thank you. I'll pass it on to Dee.
Hi, I'm Dee. My pronouns are she, her, hers. I'm in Florida, Central Florida. And I'm most excited for just like learning new things like Firebase. I've never worked with it before. I've never even heard of it until Collab. So I'm like excited to learn a new technology. And I'll pass it off to Viet.
Thanks, Dee. This is Viet Tran. My pronouns are he, him, his. I really looking forward to working with all of you because we don't really know each other yet, so it's fun to work with new people. I haven't done a lot with React yet either, so it's going to be fun to React. I'm okay with JavaScript, so I think hopefully that translates over pretty well. And how about Mike?
Hey, I am Mike Lambert. Pronouns are he, him, his. I am in Portland, Oregon, and I'm super excited for a whole bunch of reasons. One of them would be, to get to know everyone here. It seems like a really great new community that I'm really excited to be a part of. And another one would be, in preparation for this, just went through and built the app. And one of the things that I really like and feel is really artistic about software engineering in general is seeing different approaches to the same problem. So I'm really excited to see the different approaches that we maybe took and see how creative you guys are going to be.
Cool. So
Let's see. Oh, Chris.
Yeah, I think I'm the caboose on this train. Yeah, so my name is Chris. I use he, him pronouns. I'm also a Portlander. And I think the thing I'm most looking forward to about this upcoming session is the code reviews. And I'm looking forward to that for two reasons. One is because I feel like in my own career and like my development practice and experience, I've learned a lot from other engineers through code reviews. So I'm excited to kind of pass that on to y'all. And I'm also excited to like teach you about code reviews and sort of teach you how to review each other's code and stuff like that, because I feel like that's something that it's hard to get experience with, even if you've got like projects under your belt. And that's something that I personally didn't get much experience with until I actually like got to a real job. So that's another thing that I'm hoping to kind of help y'all learn. So
Awesome, super exciting. Yeah, I also did not really have any code review experience really until like a couple of jobs in, and it does feel very, the first few times that you are participating in code review, like number one, offering code review to someone or getting feedback on your pull request feels strange, especially I think the first time that you're commenting on someone else's code is like, I don't know, sure, that looks good, right? That it's can be intimidating, but that's the great thing about Collab Lab is that we just learn how to do those things and learn through practice. So, oh, and then Minnesotans are always very superior about our weather. So just know that I'll always like say how great we are in Minnesota about our weather. But really it's because everyone thinks that it's just a winter frozen tundra up here all of the time. Awesome. So Chris, I'm going to hand it off to you for your presentation.
great. Let me get sharing my screen. I got it ready to go. All right, and I guess it'll be not fully full screen, but you guys can see this well enough. So yeah, welcome to the learning module on Git and how to use it for Collab Lab. So Git, new SSH key, who dis? Git is a source control management system created by Linus Torvalds, who is otherwise known as the creator of the Linux operating system, to provide source control for developing the Linux kernel. He was really frustrated with the tools that were available at the time for a large distributed team. Usually at the time, this other system called Subversion or SVN was really popular. But there were some things that were really difficult to use SVN for. Git has a lot of advantages actually for larger teams, distributed teams, and the distributed way that it approaches its problems really solves a lot of problems for groups, especially groups like us, because we're all learning remotely together here. Some examples of why that is beneficial is like you can have multiple repositories and work offline and do all kinds of interesting things that in an SVN or Subversion world, you just didn't really have access to. Git, of course, with all of this power is a very large API with a large library of commands and options, which also, of course, means it is very configurable. So as you get comfortable with Git and as you're working with it, as you think of things like, oh, I wish it would do this, or, ooh, could I tweak this? The answer is probably yes. You just kind of have to, maybe do some Googling and figure it out. And there are many services which host projects that are based on Git where you may encounter them, such as GitHub, which is kind of one of the more popular options, now owned by Microsoft, I believe. There's also GitLab and Bitbucket, which is owned by Atlassian, to name a few other sort of competitors that are available to host Git projects out there on the internet. I think back in like the SVN days, if you ever saw sourceforge.com, I think that was like the biggest SVN repository. So kind of similar to that as well. So just a quick roadmap of what I'm going to take you through today. We're going to talk about basically a variety of different Git commands that you're going to use in order to get your work done. So we're going to talk about downloading a project, switching to a working copy or branch of a project, adding changes to staging, and saving those changes in your history with a commit. And then how to take those changes and push them up to the remote, like GitHub, and how to also pull down changes from the remote. And then we'll talk about merging changes into your branch and getting your changes into the main PR. And then finally, kind of like some things to help if you make a mistake or ways to kind of troubleshoot things. So with that in mind, let's talk about kind of the fundamental flow of how Git works, and also talk about some terminology that's going to be useful as we talk about these things. So first of all, a repository is a collection of files, like source code files, that are under source control, such as Git. We also frequently shorten this down to repo. A remote is the origin repository that is hosted somewhere online, like a GitHub remote, for example. And it's worth mentioning that a given project can have multiple different remotes, which is kind of part of the power of Git and the distributed nature of it. A branch is a working copy off of the repo. The main branch is always considered the source of truth, but you can have multiple branches that branch off of the main branch where you have other work that is being done that's not yet necessarily incorporated back into the main branch. A commit is a set of changes that are being applied to the repo, to the source code. Head is basically a pointer that at any given time refers to the latest commit on a given branch. A pull request, also frequently shortened down to PR, is a thing that documents how and why some set of changes should be merged into the main branch. Specifically on GitHub, we call them pull requests, but that is like a GitHub specific thing. You might see them referred to differently as maybe like a merge request on GitLab, but it's basically just sort of you submitting a proposal to add some changes from a branch into main. And lastly, we have a differential or diff, which is a view showing the changes that actually occurred to the code, like this line was added or this line was deleted or these characters were changed in this line, etc. So to kind of sketch all that out and kind of combine these concepts together, let's walk through a visualization of what is happening with Git and the actual fundamental data structures that it uses to store our source control changes over time. So right now we're looking at a Git tree, essentially. The initial commit is what you can think of as the root or the base of the tree. And then from there, we apply additional commits in order to build this branch along. So we might have an initial commit where we add some files at first to our repository. And then maybe we come along and add a new button component. And that might be another commit that we add to the history of the branch. Over time, as you work with multiple people on a team, you're probably going to want to branch off so that you can have multiple work streams going at once, multiple people working on different things. So maybe we create a branch that is now going to add some additional styles to that button. You'll note that the branch is in a different color here to indicate that this is work that is not yet reflected on the main branch, but it's still sort of part of this overall tree that we're building. A branch can have multiple commits. Maybe we add some tests after we've added the styles. You can add as many commits as you want off of a branch. And then whenever we're done, actually, before we're done here, while you're working on your branch on some other feature, main, at the same time is going to continue to get updates. Maybe your teammate has now updated the text of the button, for example. So that's another commit that came into the main branch. So once your work is done and you're ready to submit a pull request to merge your work back into the branch, once that merge is in, you'll create another commit which merges that work into the main branch. So at this point, we unite our work back to the source of truth, and it can all get merged down into a single line now. This is what it'll look like post-merge, where it has all of these commits together in one nice neat little history. And you can kind of imagine how that same process can be repeated by multiple people at once, and you can have a lot of different changes all occurring simultaneously on a given project as different people work on different features and stuff like that. Actually, the background is another nice little visualization of another tree here. You can actually see it with like 2 different branches at once. But yeah, so with the basic data structure and kind of how it works out of the way, let's talk about the low-level commands that you will actually be using on the terminal. I actually really enjoy the Git terminal commands. Whenever I first started programming, like the terminal for me was kind of scary almost. It's sort of, there's just a lot to learn and it's a little intimidating. But I actually found that by really engaging with Git and learning it and not giving up and like continuing to try to wrestle with the terminal with Git, I actually learned a ton. And what I learned with the Git terminal commands really cross-applied to a lot of other stuff out there, which is great. So the first command that we should really talk about is the Git Clone Command. And this is a pretty simple one. It just takes a given remote repository, which is what we're looking at right now. The repository is the website repo under the Collab Lab project. And you take this URL and you then type out git clone and paste in that URL. And that will copy down this whole Git project from the remote to your machine. The next command we'll talk about is Git Checkout. Checkout is a way for you to basically maneuver through or traverse the Git tree itself. So you can check out another branch, or you could check back out to main if you want to get back onto the main branch. You can also use this command to check out new branches with this little -b flag. It's pretty convenient. There's another syntax for creating branches, but I think this one's a little bit faster because it creates the new branch and checks that branch out for you automatically when you create it. And the remote project won't be affected by anything that you do on your branch by just checking it out. This is only occurring locally on your current copy of the project. So once you've got a branch created, you're probably going to want to start making some changes. So the first thing that you'll want to do is to add your changes to staging, to basically change them from unstaged to staged. And staged files are any files that Git will pull into the next commit that you create. So in this example, you can see we've created a button.js file. And now we're going to use the git add command and pass a path to that file. And it will add that to your list of staged files. You can also just add them all at once, which is pretty convenient, using git add with a -A. That just says, just add everything, which pretty frequently you'll want to do. Other times, though, you might only want to add certain changes over here, or there might be like a test file that you don't want to add yet, or something like that. So once you've cobbled together a few different changes and you're ready to commit that set of changes to your history, you'll use the Git Commit command to create a commit. This will take your currently staged changes and essentially write them to a document that contains the differential of what actually changed as a part of those changes. This creates a saved record of those changes to the code base, ideally with an optional message that you can pass along, telling people what it is that actually changed in this commit. So here, let's say that, for example, let's say we had updated the heading text of the page. Then we would pass a flag whenever we do our commit describing what changes that had occurred. If you make a lot of changes and don't write the commit messages, it gets a little bit hard to kind of know what's going on, or have to be able to if you have to kind of roll back time to understand what's going on, missing those messages will definitely be a foot shooter for sure. Another nice little flag to mention here too is the -A flag, which will automatically add to staging any tracked files to a given commit. Tracked versus untracked just means if there's a new file that you haven't added yet, that file is untracked. But once you've added it once, then it becomes tracked by Git. Okay, so we've made some changes. We've added them to a commit, which is just a document describing what those changes are. And now we want to take those changes and push them up to the remote repository so that they're not just on my machine, but they're on the server so that other people can access them. So to do that, you'll use the Git Push command. And usually you have to pass the remote, which you're pushing to, which in our case is origin. Origin is just always kind of like the default name that you give for usually the remote that you create, but you might have other names though. And then you also pass in the name of the branch, which was cool feature in our case. So if you don't want to have to type that all out every time, it is a little bit of a mouthful. You can pass this -u flag, which is going to add an upstream reference to that remote, so that in the future, you can just do git push and Git will already know on this branch, like, oh, okay, I have to push it to origin cool feature, and it'll just remember that. So that's kind of a useful little thing to know too. So we've pushed up our changes on our branch. Now the opposite of a push, which is also worth mentioning here, is a git pull. So, as you're doing your work, other people are also going to be pushing and pulling down changes from the server. And if you want to be able to get those changes, all you need to do is use the git pull command. And it's going to pull whatever branch that you're currently on. So let's say that you wanted to like get up to date on main, you could do git checkout main and then do a git pull to get the latest from main, which it's a good idea generally to do that before you create a new branch so that you've got the most up-to-date snapshot. And hopefully, can avoid like working off of an outdated copy, things like that. So the next command is git merge. And git merge is useful for taking a set of changes and applying them to a given branch. So this is what you will do. Let's assume like we're not using a pull request. You could use merge to merge stuff from a branch back into main, or you could use merge to merge new changes that have occurred to the main branch back into your branch. If let's say your teammate updated something and you want to pull those changes in and start working with them. Let's see, it's also just a good idea to keep your branch up to date with main, at least once a day. That's kind of like a good general idea, just to minimize the number of merge conflicts that you'll end up happening. And merge conflict it's a bit of a scary word. And sometimes they can be a little gnarly to work through, but they're going to happen. Like whenever multiple people are working on a given code base, there just will be times when you'll run into merge conflicts, and it's totally natural. But this is one good strategy to at least reduce the number of conflicts that you'll have to deal with. We'll talk more about merge conflicts in a moment here, actually. Let's see. So, let's say we've pushed up our changes. We've merged in the latest master so that we're totally up to date and we no longer have any conflicts with master. And now we're ready to show off our changes and show the rest of the team like, hey, here's my request for changes. To do that, tools like VS Code actually give you a really convenient prompt to just open up your PR for whenever you do a git push. You can see in the terminal here that the first time that you push a branch up to GitHub, it'll print out like, hey, you can create a pull request by just following this URL here. Super convenient, use that all the time. If you're using the terminal in VS Code, I think if you do command click and then click on that, it'll automatically open it in your web browser too, which will then show up as a new pull request that you can create in GitHub. This shot down here is an example of how to do that just through the UI, which is another alternative if you don't want to go through the URL here. Okay, so that kind of gives you a quick, crash course on like how to create a branch and take the changes that you want to make all the way up to a pull request. But we should also talk about, what to do in case, something goes wrong or you committed something that you didn't intend to. So Git also has a command for this. It's called Revert. And Revert is a way to basically do the opposite of a set of changes within your within a series of commits. So let's say that I made a bad commit here. Oops, made a bad commit here like this, where the message was I regret nothing. Let's say it was like a bug or just something that you want to get rid of essentially. So Git Revert takes an argument, which is the commit hash. The commit hash is just a randomly generated ID, or I think it's actually generated based on the content of the changes, but it's just a unique ID that each change, each commit has associated with it. So you can find the commit that matches the thing that you're trying to revert by doing git log. You can also pass -- pretty one line to kind of clean up and make the view more compact, but also git log on its own is nice too. And so once we've found that commit hash, pass that into Git Revert. And then what Git will do is it will create another commit that actually just reverses the changes that you made in that other commit. So, let's say that in I regret nothing, like it added a new file. If you revert that commit, then it will create a diff that just deletes that file. So it just does the opposite of what that commit was. And it's worth mentioning too that you don't even need the entire hash. They're long enough that you can usually just pass the first 10 characters or so and Git will kind of figure things out from there. Okay. Oh, actually, I want to mention one more thing in the Git Revert history too. So whenever you do the revert commit, it'll actually create a new commit in your history, and you'll actually be able to see the exact diff that it created. So it's really not destroying anything. It's not erasing anything from the history. It's actually kind of nice that you have a complete history of the changes that occurred, even the undos, so to speak. Okay, so let's talk about those dreaded merge conflicts. So really just a merge conflict is Git saying, hey, I need your help. Normally, I'm pretty good at figuring out how to merge together the different changes that you different programmers are doing. But in this instance, there's an issue and I just need you to tell me what to do, is all that Git is saying. An example of this might be, let's say you're working on a file and you added some lines of code to that file. But another one of your coworkers on another branch, maybe they deleted that file because they were doing like some code cleanup or something. That would be an example where Git doesn't really know how to resolve those two things. Like you said to add the files, but this person deleted that file. So what do I do? But don't panic, it's okay. This kind of thing actually happens kind of all the time. And all you need to do is just tell Git how to resolve those conflicts on your own. You can use tools such as GitHub Analyze against your PR to detect if there are any merge conflicts. So on your PR, it'll show you a message being like, hey, there's a conflict. And in the code, this is what that's going to look like. So Git will add these special characters, a bunch of brackets, and then head, and then a bunch of equal signs. So between that is the set of current changes. And then between the equal signs and the other brackets, that is another set of changes which conflict with this. So in order to resolve this, what you have to do is choose which of the two sets of changes that you want. VS Code actually has some really useful things for that. You can actually just click these text links up here, accept current, accept incoming, accept both, to just automatically pick which one that you want. But you can also just like manually do this just by deleting these particular characters and only leaving the code behind that you actually want to keep. So once you've done that, once you've edited the code and saved it so that it's in the correct merged state that you desire it to be in, then at that point you will add those files and then make a new commit noting that you've resolved the merge conflict with the new state of the files, and then push it up to the remote. In this case, pushing it to presumably to your branch, and then you'll be able to see on the PR that there should no longer be any merge conflicts. Okay, and lastly, there's just a resources page here in case y'all want to dive deeper on these concepts, learn more about Git. There's a link to the documentation, which is going to be super useful if you've got any questions or just want to look up how some of these commits work. Atlassian also has some really handy Git tutorials, which might be of interest if you want to work through some of these and just kind of dive deeper on Git. And also, definitely don't be afraid to Google things relentlessly if you don't know them with Git. Stack Overflow will also be your friend here for sure. Chances are good if you are like, how can I do this in Git? I almost like guarantee that someone else has probably had that same question, and you'll be able to pretty quickly find your answer through Google or Stack Overflow or whatever have you. So. But yeah, I think that is the end of the presentation here. So I'll go ahead and stop sharing, and I'll pause if y'all had any questions or anything you wanted to ask me about that before we move on. But I think I'm like 1 minute off here. I think I was just on time. So.
Oh, it's perfect. Yeah. What questions do you have?
I've got a couple. I'm wondering, so that with Git add all, is there a difference between the dash capital A and the add with the dot? And then can you only, should I ask them one at a time or just?
Feel free to ask the second one. I'm going to Google the first one.
Okay. And then can you only set one branch with that dash U where you're trying to tell it what you want to push to automatically?
I believe you can only set it to one branch at a time because the information that the dash U is taking is two things. It's taking the remote, which is origin in our example, and the name of the branch, which is like cool feature. So any given like upstream setting is for a particular branch. So then when you create a new branch, you'll have to like repeat with the dash U. because that the branch parameter will have changed for the new branch. So
Makes sense.
but let's see. So this is a good one. I don't actually know the answer to the difference between the dot and the -a off the top of my head. I actually use git add dot in my personal workflow whenever I'm working. This presentation just had -a. I think that they both work. And if someone can find out and share with the group, you get an internet cookie, I guess.
Yeah, I use dot too. So I'm trying to look if there's a difference between just doing git add dot and git add -A.
I've also usually used dot whenever I wanted to add everything. Chris so I've always been confused by the revert versus reset, and I've read a few things on that. Do you know, or can you explain the difference between the two?
Yeah, totally. So revert is going to create a new commit, whereas reset is usually used to undo a set of staged changes or even undo a previous commit. But the difference is that reset isn't going to create a new commit. It's actually going to only potentially get rid of commits. Like if you did a git reset head -1, that would basically say unapply the last commit, and then the changes that you had from that commit will be staged instead of in a commit. Now that's me just knowing the answer and telling you because you asked. But for the purposes of Collab Lab, my understanding is that it's actually preferred to use revert in this case because we want to retain the history of what has occurred. Because it's just for learning. Like if you were at a company and really committing source control to like a real project, you'd more likely have cases where you're like resetting or rebasing and rewriting the history to clean up like your git commits and stuff. But for this, we want to encourage people to just kind of like leave a thorough paper trail. So even if you're like, oops, that was a bug, let me just fix this real quick. A revert is a little bit more useful and informative to other people than if you had done a reset and then just like changed it. Or if you'd even like done a git commit amend where you can change what occurred in a commit or different things like that.
So with revert, can you also do the tilde like to go back to commits, or is that does that only work with reset?
I haven't tried it. I always just pass the commit SHA, but it would actually be really convenient if there was a syntax to just say go back to, because like sure, I'd use that all the time. I don't know.
Okay.
If you find out, let me know. I'll use that.
All right.
And then, oh, sorry, go for it, Dee.
Oh, are you sure?
Oh yeah, go for it.
Okay. So I know that Git pull is like a combination of Git fetch and Git merge. Is there a reason why you would do just Git merge rather than Git pull?
Good question. So I guess like the difference between pulling and merging in my mind is like if I'm on a branch and let's say my teammate added some more commits to the branch and I just need to pull those new commits down, I'll just use git pull because I'm on the same branch, right? Merge is when you want changes that are from a different branch entirely. That might be from the main branch, or it could even be like you have a teammate who has a bug fix and you just want to kind of also have that bug fix in your branch. You could pull their branch into your branch or something like that, which will do the merge. But then there's maybe kind of another answer that I can give too here, which is I guess the difference between doing a git pull from main versus like a rebase. Is that also kind of what you're asking about, or?
Well, I don't know. I've never done rebase, so I'm not familiar with it.
Cool. So for Collab Lab, all you'll really have to worry about is just doing a git pull from main. You can also do a git fetch and then git merge main into your current branch. Either of those would totally be fine. And then for one reason or another, that's kind of just how Andrew has it set up and has it preferred. Another option would be to use rebases, but we won't go into that for Collab Lab. Does that hopefully answer the question, or was there more there maybe?
No, that's good. Thank you.
Cool.
And then, so is it common to like have merge conflicts and be like, oh, I don't know which one maybe I need to talk to this partner over here. Okay, cool.
Definitely, yeah. That happens to me a lot at work, where I'll be doing something and then like, whoops, some other thing that I didn't really know was going on occurred, and it's just like, oh wait, is it this function or is it this function now? Like, I don't really know. So sometimes I can answer that on my own just by like reading other people's source code and like looking at the commit history. Sometimes it'll kind of make it clear. But yeah, sometimes you're just stumped. And then the best thing to do is just like reach out to your teammate, ping them on Slack, or just like at them in the pull request and be like, hey, there was a conflict with your work here. I think this is what it should be. Does this look right to you? You know, which is a great opportunity for code review, right? So.
As far as so I haven't used this workflow really well in the past, but generally, if you're on a branch and there's an update to main and you're working, you generally have to stash what you've been working on. Is that right? To pull from main to get like the
Correct.
most recent changes, right? And then you can then re-implement your stash back into what you've just pulled.
Yeah,
Okay.
that's totally what you can do. I use Git Stash decently often for that exact purpose. Another option is you can always just create a commit of your current work. You know, you could just be like, commit, work in progress. This is currently what I'm kind of doing. But that's also not as clean of a Git history either. So I think using Stash is a great option too, which just for anybody who's not familiar with Stash, that just takes the current set of stage changes and then basically just like hides it somewhere else temporarily. And then later on, you can pull those changes back out of the stash with Git Stash Pop or Git Stash Apply. So
I don't know if you guys are like me, where you'll have like just a deep stash going at any time.
I tend to
And
do like a mixture of the two. Sometimes I'll stash it, but I tend to not care as much about having like the most pristine Git history. I don't mind committing things that maybe I'm not as proud of, that maybe I'll be working on later.
I'll do the same thing. And then sometimes what I'll just do is I'll actually rebase and then sort of rewrite my messages to be a little bit like cleaner, combine certain commits and stuff. But that's kind of advanced stuff that we won't necessarily like make y'all do for this, but it might be something that you end up doing one day. So
with just to go back on stashes, you can also have a message for the stash. Is that right?
Mm-hmm. That's right.
Okay. Because otherwise it's just going to be numbered sequentially or something like that, right?
Yeah.
Okay.
And it is a stack. So whenever you pop off of the Git Stash stack, it applies the most recent thing that you just stashed. But if you've got a bunch of stuff stashed and you're like, oh, wait a minute, it was actually like the third thing back that I wanted, to get that, you do Git Stash Apply. And then I think it would be 2 because it's 0 index, so like 0, 1, 2. And then it'll pop the third thing off for you. I'm impressed by the advanced Git questions. This is great.
Does anyone on the team use any kind of GUI or anything like Git Kraken, or do they use the GitHub interface? I know some people do use that, so just wondering.
How about the source control in your code editor? Do you guys tend to use your terminal or the IDE for Git things?
I generally do everything through my terminal, except for pull requests.
Same.
I've used the VS Code source control. I like it to like stage changes one at a time. I feel like it's easier, and then you can write a commit for just what you've staged instead of just adding everything. And I like it, but I've used both.
Cool. All right.
Sounds like that's maybe all our questions.
Nice. Thanks, Chris. That was awesome.
Totally.
Cool. I'm excited about that one. Okay. All right, Mike, I'm handing it off to you.
All right. Cool. So I'm just going to go over the upcoming issues that we're going to have for the week. And, you know, one of the really important things in working on projects like this and group projects is having a really clear idea of what the requirements are, and what's the expectation of each of these, what's our goal. So ask as many questions as you'd like, and yeah. So the first one we have is that as a component, I want to be able to read from and write to the Firestore database so that users can persist information. Now this one sounds both like a lot and a little, I guess, to me, which it seems like it could be interpreted that we're going to go and create all of our entire database models and everything like that. But in reality, what we really want to do is we just want to be able to store information in the database and then read information from the database, right? And in this case, our database is Firestore. So we want to, we'll be adding the Firebase and the React Firebase hooks dependencies. So in our package JSON, we'll be making a change in the Firebase database so that it shows up in the app, and then making a change in the app so that it shows up in Firebase. And for this, you can totally just like use a throwaway button or something like that, just so that you fire off a post request or a request to create some data, and then just somewhere to display it, and then you can throw that away at the end of the day. Questions on this one?
So, Mike, you just mentioned a GET and POST request. Is this like a file IO thing, or is it, or is it more of like like an API request?
Yeah, it's an API request, and we're using the like React Firestore, which has its own built-in, I guess, create methods, and I forget what the actual methods are, and you'll probably have to do a little bit of reading of documentation in order to get familiar with how to do a create and how to do a read.
Okay.
Yeah. Other?
So it sounds like we don't necessarily need to be adding and reading what our final goal is, like the items, just literally anything, like
yeah,
the world or okay.
Exactly. This is really just, this is why I say it's a lot in terms of, this is super important that you connect to the database, right? And for me, it's always, these kinds of things are where I tend to struggle. But at the same time, it's really not much, because all you have to do is connect to the database. So it's, again, we don't want to, the goal here is not to create all of our data models or anything at all. It's just hello world, create something, read it back. Okay.
And not a question, but a comment. I was doing some digging through the app, and I found where that the Firestore database has already been configured. So if anyone wants to look at that together after this meeting or at any point, just message me.
Nice. Cool. Any other questions on this one? And as you're going through any of these, if anything is not clear or anything like that, discuss it. For me, I know that one of the most difficult things is oftentimes source of miscommunication typically comes from misinterpreting or just having different ideas around stories. So you should always seek to clarify whenever you need to. So the second one is also a bit of setup. So this one is, as a user, I want to be able to navigate between a list view and an add item view so that the interface is clearly delineated between viewing and adding, right? Now, what this really means is that we're going to be using React Router DOM, and we're going to have links at the bottom of our GUI in which we will switch from a list to an add item, and the URL should update when you click the buttons, right? So the links are present and persistent at the bottom of the app, so they're always there. One says list, and another one says add an item. And when one of the links is clicked, the browser URL updates to represent the current view, and a matching view is displayed. And whichever one is selected should be bold. One of the things here, these are all just ultra setup stuff, and we're gonna have a ton of time to make everything look really pretty down the line. But for right now, it's just getting the main nuts and bolts in place. Yeah. Questions here? Okay.
Sorry. Yeah.
Yeah.
I'm like trying to find the windows to unmute myself. So links are present and persistent at the bottom of the app. Is there, when we do some digging into React Router DOM, will we probably find like the structure, or does that mean that it should be in the app component itself?
In terms of how you want to lay out the components and where the routing goes? Is that?
Yeah, I seem to remember there is a structure and there's good documentation on it. I just wanted to make sure.
Yeah. Usually people would have the routing in the main app.js, and as you said, React Router has some great documentation in terms of what ends up as what component and how things are broken down. This is really your project. So those are the kinds of things that you can discuss and say what owns what, where does this live, those kind of things. And those are always the really fun and important discussions to have. Cool. All right. Well, that's all that I have. I think it's just the two. Is that right, Lauren?
Yeah, so we'll just, each team will work on one issue. So I know Chris is doing this part, but so Brittany and Rachel are working together this week as a team, and then Dee and Viet are working together as a team. So it'll be up to you all get to decide which issue you'd like to pick. So if anyone, Chris, I'll hand this out to you, but if anyone has any strong feelings about which one they're most excited about, go ahead and speak up.
Don't all speak at once.
I'm happy to work on anything if someone has a strong preference. So
Maybe
that's not super helpful, but
maybe we just flip a coin or something like that, and since we're all kind of indifferent right now.
We could always decide that. Oh, do we need to decide that for the next step for creating our? Gotcha.
Yeah.
Okay.
If no one really has a strong opinion, we can just do like Brittany and Rachel, you'll take issue 1, Dee and Viet take issue 2.
That sounds great.
All right.
Cool. So I'll go ahead and share my screen again real quick. And I think what we're going to do is just walk quickly through how to create the branches that you'll be working together on, and kind of how to push them up and get them all situated. So let's see, you should be able to see my VS Code terminal right now. Let me bump up our screen size a little bit. So right now I'm just on my personal fork of TCL 00 Smart Shopping List. And let's see, let me ask real quick, Lauren, do we have any particular like branch naming recommendations that we give? I've got an idea, but I just wanted to check with you.
Yeah, we usually do initials dash brief description.
Cool. So, oh, that was weird. Okay, so if I wanted to follow that, I would do Git Checkout -B, which, as you remember from the presentation, is shorthand for create a new branch and check that branch out. And I'm doing this from the main branch, so we're branching off of main. And so my initials would be like CD, and I'm gonna just imagine that I'm pairing with Lauren, so LB, and then you said initial description, right?
Yep, then just a brief description of the issue.
And so for me, I'm just gonna call it demo branch, why not? But in y'all's case, you'd do something like add Firebase connection or something like that, you know, based on what your ticket is. So I'm going to hit enter, and now I've created this branch, and it's also checked out that branch. So once I've created the branch, you actually don't technically have to have any commits in order to push a branch. So I'm just going to do git push, and don't forget the -u flag in order to set the upstream for this branch. And I'm going to pass in the name of the remote, which is just origin. And then I'm going to pass the name of the branch, which is CD-, and I'm lazy, so I'm just going to hit tab to autocomplete it. So it autocompletes there for me. And then I'm going to hit enter, and that's going to push it on up. Cool. And then remember that you can command click on this in order to automatically open up the branch pull request in GitHub. But of course, since I have no commits, there's really nothing to look at here. But you can follow this link again later, or you can always just go to pull requests and click this new pull request button once you're ready to create your PR. And feel free to get those created early if you'd like. You can use the draft PR format and get some early feedback from your teams or from us if you'd like. And yeah, so that's pretty much the demo for how to create the branch. I'll pause there and then give y'all time to get your branches created. And I guess it's worth throwing out there that only one of the two people on each pair needs to create the branch because you're both going to be working off of the same branch. So I guess now go ahead and decide amongst yourselves how you want to handle that.
Rachel, do you have any preference?
No, you can go ahead, Brittany, if you want.
I've got it open, so yeah, I don't mind as long as that's okay with you.
Go for it, yeah.
Okay, cool. So Brittany will create it and then she'll push it up, and then Rachel, you can pull it down. And then we just want to make sure before we leave the call that you're set up and everybody has everything that they need. Do you know what I mean? We just want to make sure everyone's set up for success for the week. And then Dee and Viet, who would like to create the branch?
Yeah, does it matter? I mean, I have it in front of me, so.
Okay, yeah, go for it.
Go for it.
Okay.
I'll just leave my terminal up so you can look at that if you need to.
Perfect.
I'll also type out what your team members will want to do in order to pull them down. So really what I'd recommend doing is doing a git fetch. And whenever you git fetch, it's going to pull down any other changes that have occurred to the repository. So for you, once the branch is pushed, it'll show new branch, whatever. And then once you've done that, you can git checkout, the name of whatever other branch it is. So in our case, we would be just doing this CDLB branch. Of course, we're already on the branch though, so that didn't really do anything for me, but those will be the commands that y'all will use.
All right, I have pushed that branch.
And I have checked it out.
Awesome.
Sweet.
Great. Very cool. I see it. Very exciting. Cool. And then while everyone is finishing up, I put threads, your pairing threads in the list. So that's a good place, again, to kind of organize your research and your collaboration for the week. Yeah, so I'll do that. I'll do that every week at the end of our meeting.
I pushed our branch yet.
Okay.
Nice.
And Lauren, could you repeat where you said those threads are set up?
Oh yeah, if you go in our TCL 17 channel, and then you'll see this weird TCL 17 pair bot post.
Okay.
Do you see it?
Is it at the very bottom or is it somewhere else maybe?
Let's see, there are a couple of them. So do you see where I posted the Zoom link, or I can share, or no, I can share.
Here, I can stop sharing.
Okay, cool. Cool. I will share. That's the right one. Oh, just moved my thing. Am I sharing the right thing? Do you see Slack?
Yeah.
Yes.
Okay, good. Okay, so I think that I'm in TCL 17, and there's this TCL 17 pair bot.
Got it.
Right, so there's a ton of information, but it says that Brittany and Rachel are going to be working on this, and then a little bit further down, kind of in that same thing, D and yeah, this is your thread. So like underneath here, D and yet can post things. Here. Does that make sense?
Yes, thank you.
Yep, and then Brittany, Rachel's thread. There we go. Then I got it started, and then it'll be a little bit easier to find. I know it's one big like wall of text.
And
Thank you.
Andrew just commented on that. I believe he was like, not sure what's up with the pair bot, but ideally the second message is where it posts the link to the issue.
Okay. All right.
All right.
Does everybody have their branches yet? Do you have yours pulled down?
I haven't pulled. I'm having. It's not letting me switch over to the branch because of the package lock JSON. It's saying there are changes there. So I think I might have to commit or stash whatever changes were there.
Do you want to share your screen?
Sure.
Okay, and then are you on?
Should be, I'm on main right now.
You're on main. And then
Yeah.
if you do, so did you do just npm install or something?
Yeah.
So I would just do, I think if you do Git Checkout -- dot, I think that'll work. And do that. I think that'll, now what does it say if you do Git status?
I think, is that error out?
It might have. What does it say? It might be, let's see, I always do things from muscle memory. So if you do Git checkout -- you might have to do -- space dot.
Okay.
Try that. Now do Git status again.
There you go.
Okay.
What was it?
Oh,
Dash
list add routes with dashes in between
what was the last word there?
route
Just no S
with an S.
with an S. Okay. Okay. Cool.
Nice.
All right.
Perfect.
Awesome.
Yay.
Yay.
Good job, y'all.
All right.
Cool.
Nice work, everybody. Okay. Very good time. Hooray for us. So your threads are in the channel. I guess the next step is that you'll just want to make plans for when you all want to get together and decide, to decide when you're going to pair on your issues. And the goal really is to shoot for having that PR up and ready by, I would say, Thursday at the latest. That would give everyone enough time for code review. But please be noisy in Slack, ask questions. We'll be noisy in Slack just to check in and see how everyone's doing. Cool. All right, I'm super excited.
Cool. Good luck, y'all.
Thanks, everyone.
Thanks,
See ya.
everyone.
Bye.
Take
Have fun.
care.
Bye.